This is a quick, no-nonsense lesson about multivalent nomenclature. When we look at a formula, we need to determine if it is ionic or covalent. That's the first thing that we do. When we look at potassium and we look at iron, they're both metals. Here is potassium, okay? And iron is located right here, okay? Now I'm circling the charges that they have. Multivalent means more than one charge, or multiple charges is actually a better way of defining it. So this one is going to be multivalent. Okay, check. This one, potassium, is not multivalent. You can see that I wrote their names out. Potassium sulfide. You also notice that the "ide" at the end is always written for the second element. In this case, it's the anion. For the second one, I have iron bracket oxide. I've included those brackets because iron can have multiple charges. Now here's a big hint. Look at the charge of the nonmetal to help you determine the charge on the metal. So if we look at our nonmetal for iron oxide, we can see that oxygen has a 2 negative charge. Again, remember, iron can have multiple charges, 2 plus, 3 plus, or 6 plus. So in this case, iron could have a 2, it could have a 3, or it could have a 6. Now the 6 isn't very common at all, so it's probably not going to be that. But you have to decide what Roman numeral, this is 2, this is 3, and this is 6. Which one gets to go in the brackets? And the one that gets to go in the brackets is the one with the right charge. And the right charge is the one that balances out the nonmetal's charge. Remember that these are ionic. The little number that's written down here, it looks like there's nothing here, but you need to remember that these are the subscripts. And the subscripts tell you how many atoms you have. In this case, we have 1 iron and we have 1 oxygen. I'm going to draw the oxygen as a square, and remember it has a 2 negative charge. That is the anion. And the anion has to match up with a cation, and their charge has to be neutral. So if we look at this, 3 will not belong, 6 will not belong, but 2 will. Because 2 plus and 2 negative, they cancel each other out, and all these ionic compounds want to be neutral. So the answer to this question is iron 2 oxide. So let's try another one. Here we have Cu. Cu is a metal, therefore I know it's ionic. I'm going to write down copper oxide. Now remember from our periodic table that oxygen has a 2 negative charge. We know that we need to use Roman numerals if copper has multiple charges. Let's find copper on the periodic table. Copper is multivalent because it has multiple charges. It has a 1 or a 2. So what charge belongs here? Well, we need to look at, again, the charge on the nonmetal. Here we have 1 oxygen with a 2 negative charge. So 1 oxygen with a 2 negative charge. We have 2 coppers. The question is, what charge has to go in each one of those circles for this to be neutral? If I put the 2 in, which is right here, if I put the 2 in, it wouldn't work because the positive charge would not match the negative charge. If I had 1 plus 1 plus, that adds up to 2 plus, and that cancels out that negative charge. Ionic compounds want to be neutral. So the answer is copper 1. This is going to be copper 1 oxide. You have to write the charge on the individual metal cation to know what it is. Another trick way that students will just say is, well, let's just reverse crossover, and then I'm going to write this charge right here as my charge that goes in there. That doesn't always work. It's often better to think about and understand that these are cations and anions. So let's look at another example. This one right here is Zn3N2. Zn3 says that has 3 zincs, and N means 2 nitrogen. Now, where is zinc on the periodic table? If it's a metal, it's going to be ionic. Now, I remember zinc is a metal, so therefore it's going to be made up of ions. It's particularly going to be made of 3 positive ions, 3 zincs, and the 2 means 2 nitrogens. And what I'm remembering is that overall this charge is going to be neutral. So zinc would be the name, and the second one, which I recognize as nitrogen, is going to be nitride. Now, in order for me to use Roman numerals, zinc has to have multiple charges. Let's look at the periodic table. Here we have zinc, and if you look, it has a 2+ charge. It does not have multiple charges like, for example, manganese has multiple charges. Zinc does not. So therefore, we don't need Roman numerals. So the name of this compound is zinc nitride. Okay? Now, just to show you quickly, I want to show you the charges. The charges still match up. Nitrogen, which is in group 3 or group 5, will have a 3 negative charge, which adds up to a total of 6 negative because there's 2 nitrogen or nitride ions. Zinc, we just found out, has a 2+ charge, and there's 3 of them. And that adds up to be a 6+ charge. So the charges still matter, but do we care about the charges? No, we don't. Why don't we care about them? Because this is not multivalent. So the answer is zinc nitride. Okay, I'm going to go over a polyatomic example quickly. If you haven't learned about polyatomic ions yet, you can stop the video. The way we do polyatomic ion naming is we just look to see if it's a metal again. Lead is a metal, I know that, so I write down the name. I then look at the periodic table. Lead is located right here. It is a metal. This is the staircase right here. So it is on the left-hand side. And you also can see that it has multiple charges, either 4 or 2. That means it's going to need multiple charges. That means it needs Roman numerals. So we need Roman numerals. We can either have a 2 or we can have a 4, which is IV. Okay? One will go in there. One will work. And to understand this, we need to know what polyatomic ions are. This is a polyatomic ion. It is sulfate, and we just have one of them. What's the charge on that sulfate? Well, this is a memory thing, or you have to look at the back of your periodic table often, is 2 negative. This means that when we look at sulfate here, we have one sulfate. It's got a 2 negative charge. How many leads do we have? Well, we have a subscript of 1. So that means that we have 1 lead. What charge would go in here to make it neutral? Well, the answer is 2+. 4+ will not work because it will not be neutral. 2+ and 2 negative make 0 charge, neutral. So the answer is lead 2. So this is going to be lead 2 sulfate. I'm going to clean that up for you. And that's your answer, lead 2 sulfate. So what about name to formula? Well, this is a bit easier. Whenever you have Roman numerals, you treat it like it has a charge, like it is ionic. And we know lead is an ion. We know lead. Whenever we write it superscript, we're going to write our charge. It has a 2+ charge. Chloride, which is in group 7. So when we look at the periodic table for chloride, it's in group 7A. And everybody in group 7A will have a 1 negative charge. So that's our 1 negative charge. What we do is we just cross and reduce. So this will become PbCl2. Again, if you do these rules, you're going to create a neutral compound. So we have 1 lead with a 2+ charge, and we have 2 chlorides with a 1 negative charge. We have 3 ions total. Overall, this whole thing is going to have no charge. Here we have one last example for you. This is tin. Tin is a metal, and again, I recognize it has a 4 charge, so I write tin. Look on the periodic table, it's Sn. It has a charge of 4+. I look at sulfate. It ends in ATE, so that tells me it's a polyatomic ion. So I'm going to write that as SO4 2 negative. Now, right now, we have 1 of each of these ions. It's not neutral because it would look like this if this is the case. It would have a 4+ charge and it would have a 2 negative charge, which is not neutral at this point. So what we do is we cross and reduce, and you'll see how it becomes neutral here. So what I'm going to do is bring down the 4 here, and I'm going to bring down the 2 here. So the 2 came down like that, and the 4 came down like that. Okay, and what happens is you now have a 4 and a 2. You can see this looks like 44 right here. You got to remember, whenever you cross over to a polyatomic ion, you have to put it in brackets. Now this is saying that we have 2 tins and 4 sulfates, which is going to be neutral, but you always have to cross and then reduce, always. Okay, so how do we reduce 2 and 4? Well, that reduces to 1 and 2. So this goes to 1, and that means we're not going to write anything because that means 1. And this 4 is going to go to 2. So we reduced 2 and 4 to 1 and 2, and that means we now have 2 sulfates, right? And it's matching with 1 tin. Remember the charges that I just erased here? 1 times 4 is 4, and 2 times 2 is 4. This is going to match up charges. This compound is neutral. So the formula for tin 4 sulfate is SN bracket SO4 2. That's it.